Reading your instructions. It says use the given function values and trigonometric identities, including the cofunction identities, to find the indicated trigonometric functions. Oh, snap. Here are your cofunction identities. If you guys think about it, this stuff makes a lot of sense. Now, check this guy out. Now, pick a theta. Any theta.
45.
No, one that's in your circle.
45.
Okay, no, not that one. That's a bad example. Let's do 30. Sorry, I know. I said pick anyone, and then I said, no, I'm not listening to you. So let's pretend that theta is 30, so cosine of 30 degrees. Do you guys know what that is? Look at your unit circle. That's right. It is rad 3 over 2, right? You guys got that? So we got rad 3 over 2. Now, the other side would be sine of 90 degrees minus 30 degrees. What do you get? Well, that would be 60 degrees, right?
Yeah.
What is sine of 60 degrees? Holy crap, it is also rad 3 over 2. Wait. So you know what this means? Do you know what theta and how theta and 90 degrees minus theta, you know how this angle and this angle are related? They're complementary angles. And so if you have complementary angles, then you have these cool cofunction identities. Yeah, wow is right. Now let's go back to our other problem. So now when I'm looking at this guy, I can see that cosecant is this and secant is this. Oh look, we're going to need that cofunction identity down here. There's other trigonometric identities that we're going to be considering. And if you guys go earlier in this section, you can see a listing of them. Now, let's list them all out. We got sine of theta. We got cosine of theta. There's tangent of theta. Let's see, cosecant of theta and secant of theta, and last cousin, cotangent of theta. All right, so we know that cosecant is rad 13 over 2, and secant of theta is rad 13 over 3. Now, here's a cheater way to do it. You could say, nah, I don't want to use identities. I'm going to make a triangle. And you make a triangle, you just go, well, I definitely know that the hypotenuse is 13 because cosecant is hypotenuse over what? Hypotenuse over what? Opposite. So we know that the opposite is 2, right? And then we also know that, yeah, the adjacent side would be 3 because we know what secant is. So now you have your triangle. Now you can find all these guys. That is the cheater way of doing it. Doing it that way is not needing, you're not going to need the identities. And so just make sure you don't end with a radical, a square root on a denominator, and you're good. You go. You can get them all. I can get them all? Yeah, you can. Even you can get them all. Oh, that's great. 2 over 3, and then this one would be 3 over 2. So, how would you do it if you didn't do it that way, the cheater way? How would you use identities to find it? Well, this is what you know, Stews. This is what you know. You know that sine of theta equals 1 over cosecant of theta. Why? Because they are reciprocal functions of each other. That means that you could have just looked at this guy and flipped them to get the sine. Are you guys following?
Yeah.
Okay, that's an identity. That's a trig identity. Okay, the same thing with cosine. We could have gotten cosine by taking secant and flipping it because we know that cosine of theta equals 1 over secant of theta. And this works both ways. So if we went cosecant of theta, we could say that equals 1 over sine theta. And same thing with secant theta. We can say that equals 1 over cosine theta. And that is also true for tangent and cotangent. You can write the same thing. These are called reciprocal identities. One more identity that is important, and that's known as the quotient identity. The quotient identity is this. Tangent theta equals sine theta divided by cosine theta.
What?
That's a quotient identity. This is usually representative of the opposite side, and this is representative of the adjacent side. And that's what tangent is. Opposite divided by adjacent. Oh.
That's weird.
But what do you guys think cotangent is? Yep, cosine theta over sine theta. These are quotient identities. There you go, guys. We got quotient identities. We got reciprocal identities. And, oh, look, I wrote extra. We only had to find sine, tangent, and cosine, and this guy.
This guy.
Oh, snap. That guy. Wait. That's supposed to be equal to who? What is secant? What is the cofunction of secant supposed to be equal to? Is it sine, cosine?
Yeah.
Nah, not
Cosecant.
cosecant. Yeah, so this is supposed to equal cosecant theta.
What?
See, here it is, right here. Secant of 90, the complementary angles right here. That equals cosecant theta. Now, which one of these? Oh, all these identities, the sign doesn't change. Oh, that's kind of cool. Rad. That means that this guy right here equals rad 13 over 2. Yay!